Let's do some hands-on. So what we'll do is that we'll load orders table using copy command. Actually, we'll load two tables, orders and orders underscore 2. Then we'll check the size of the table using SVV table info. Then I will perform an update operation. And after performing update operation, I'll check the table size again. Then I'll perform a delete operation and check the table size again. After that, we'll check the unsorted rows using SVV table info table. And then we'll run only vacuum delete operation. After vacuum delete operation, I'll run vacuum full. Now these two would be on the two different tables. So one is orders and the other one is orders underscore 2. And then we'll run analyze on the orders table. We'll also run analyze compression to see whether we get any update or not. And we'll look at the system table for vacuum and analyze. Okay, what I have done here is that I have loaded the tables orders and orders underscore 2 with 100 million rows using the copy command. So this is the copy command that I had used for orders underscore 2, and if I do a count star on retail underscore orders, you'll see 100 million rows. Let me show you. So the number of rows in orders is 100 million, and orders underscore 2 table should have the exact same number of rows, as you can see here. Next, what will I do is that I will check the size of the tables. This is the query, SVV table info. I should see orders and orders underscore 2 both. So the database is 3IMDB. This is the schema, table ID, and these are the two tables. And if you see, the size of the table is 5.7 GB. So this is in 1 MB block, so approximately 5.8 GB actually. But I had loaded the table with 9 GB of data. So that means the compression actually worked this time, and after compression, the size of the table has become 5.8 GB or 6 GB. So from 9 GB, it has come down to 6 GB. 3 GB was compressed. Alright, so both the table size are same. I'm updating both the tables, update retail.orders and orders underscore 2. All the rows should be updated because all 100 million rows should be updated. Both the tables have been updated. So if you see, for orders table, 100 million rows were affected. Same is the case with orders underscore 2 table. Now let's check the size of the same tables again. So it was 5.789 GB earlier, and if you see, the size is 11.3 GB. So what happened was that all the rows were deleted and inserted again. So the table size has changed to 2 times, from 5.789 to 11.290, approximately 1.9 times. So as you can see that what update is doing, it is not only updating the rows, it is deleting the rows and inserting again. So that's why the size of the table has increased 2 times. So earlier it was 5.8 GB, now it is 11.3 GB. Now what will I do is that I'll delete the rows from both the tables. So all rows got deleted, or actually got marked for delete. And if I check the size again, so for both the tables, the size is same. The size has not changed at all. So it is 11.290 for both the tables. And this was the size after running the update statement. Now what will I do? I will run the vacuum delete only command for retail.orders table and vacuum full command for orders underscore 2 table. Both the commands are done. Vacuum delete only took approximately 2.6 seconds and vacuum full took 38.4 seconds. Let's check the size now. So both the tables are gone because there's no size. There are no blocks which are there in these tables. So that's why it is not coming in SVV table info, which means that the tables are completely empty. Now I'll go ahead and run analyze command. Analyze command is pretty straightforward. There's nothing much to show. We'll come back to analyze command in the performance tuning section. But before that, I am using this predicate columns view. So I'm using this statement to create a view called predicate columns. So what it will do is that it will tell you which columns are used as predicates. It is done now. So if you see, the time was 101 milliseconds. And if you have to query this view, you have to mention like this, predicate columns select star from predicate column, so a table name like orders. So as you can see, none of the columns are predicate column because I have not run any queries on this particular table after creating and loading it. So what will I do is, now I will load the table again and run some queries using some predicates. Again, I mean, we'll mention where clause in in order by and in group by. So let's see whether those are captured as predicate columns or not. I'm loading the table again with orders underscore 1 CSV, which is 9 GB in size. After that, I'll run some queries so that the predicate columns are captured. 100 million rows have been loaded to orders table again. Now what will I do is, I'll run some SQL statements so that the predicate columns are captured. I might not see any output, that is fine. The reason I'm not seeing any output, because I have taken this order ID from a different file than orders underscore 1.csv, because this is a very big file, approximately 9 GB, and I'm using the split file, so that's why there are no rows. Same should be the second one, it should not be any rows, and the third one, it should not return any rows. So as you can see, there are no rows. Now let me run a query with order by clause, wherein I have put order date in the order by. It will show me 100 rows only because I have put limit as 100 here. So I can see some output, and I'll run one more query wherein I'm placing order date in the group by clause. So I can see some output here, 100 rows approximately. And now let's look at the predicate columns again. If I see in the retail orders, in the order ID is predicate column has been set to true, and for order date also the is predicate column has been set as true, because I have used order ID in the where clause and I have used order date in the order by and group by clause. What I'll do is that I will add payment method now, and I'll add payment method in the group by clause. So this is the total price, and if I run query on the predicate columns view again, so if you see, the payment method is also considered as a predicate column because it was there in the group by clause. Now I can analyze the table. So I can run analyze retail.orders on the predicate column. So analyze would be run only on payment method, order ID and order date columns. Let's check the analyze compression also. If we change the encoding mechanism of customer ID to AZ64, then we'll get an estimated reduction of 36%. Same is the case with seller ID. In order ID, no estimated reduction in percentage. In order price, if we change it to AZ64, we'll be able to save 61.54% on storage. And if we change the payment method encoding algorithm to byte dictionary, we'll be able to reduce the storage by 91.72%. If we change the encoding theme of all these columns, we'll be able to save fair amount of storage. Now the next one is, let's take a look at the system tables for vacuum and analyze. So I'll only show you the sys vacuum history and sys analyze history. You can take a look at the rest of the tables on your own. So as you can see, we have so many rows of vacuum history for order tables, but we had run vacuum only today. If you see here for retail, these are the two vacuum commands that we had run today, vacuum type delete. But if you see here, there's a column called is automatic. So if it is if, that means it was a manual vacuum. If it is true, that means it was an automatic vacuum which was run by Redshift automatically behind the scenes as a background thread. So as you can find the status also, it is vacuum BG, meaning background process. So as I was telling you that Redshift automatically runs vacuum delete only statement or vacuum delete only command in the background automatically. Now I'm checking the sys analyze history for the same table orders, and as you can see that I had run orders on the retail column today, There's another order table in the public schema also, and analyze has been running there also. And as you can see, is automatic is true for all the cases. This is the full analyze, not the analyze on certain columns or predicate columns. Now let's take a look at SVV table info again to check the vacuum sort benefit and unsorted columns. Now if you see here in unsorted, it is 100, meaning none of the rows are sorted. Now, even though the rows are unsorted, and if we run the vacuum sort only command, it will not give us any benefit. So let us not do that. So this is one of the ways that you can actually check whether a table needs a vacuum sort or not. And delete only is something I have already told you. If you are running update and delete, a lot of update and delete statement on a particular table, you should anyway run vacuum, or Redshift will automatically run it behind the scenes. Okay, so these are the table IDs in this particular database, and then what it says, the first one is STAI rows. It is the total number of rows in this particular table. So this is, I think, orders table which has 100 million rows. The second one, STAIINS, which shows the number of rows inserted since the last analyze. And the last one, which is STAIDELS, the number of rows deleted since the last analyze. So if it goes pretty high, then you should run analyze again.